Hey guys, today we'll be solving an iOS systems design question that is called Steam Friends List. Let's imagine we need to develop a companion mobile app for Steam to show a friends list and the statuses of your friends. Let's take a look at the mockup. So in our app we will have only one screen, basically a list of friends, and for each friend we would need to show an avatar, just a small image, a name of your friend, if your friend is online or offline, and what game he or she is playing. So basically here we are showing playing World of Warcraft. And if your friend is offline, we need to show when he was last seen. So for second friend, we are showing last seen 2 days ago. And we need to sort our list by the last seen or online status. Alright, so this is our problem statement. Important thing here is that before you start doing your architecture, you always need to ask the interviewer questions to clarify the problem, to understand it better. Let's do it, but I will answer the questions myself. Okay, first of all, we need to understand how many friends could we potentially have. It's a really important question because if we have a lot of friends, possibly we would need to have an pagination to download them in chunks or some additional logic. So let's say for this problem we have less than 500 friends. So basically it's not really much. Okay, so second question is, do we need an offline version or some kind of cache for this thing? Let's say that we need cache. So I will write here need caching. And the next interesting question is how often we really need to update this last seen status. For simplicity, let's say it would be every 5 seconds. So it's important for user to see if his friend is playing some game or online at the moment, so he would be able to message that person. So it's really important to know that at least with 5-second delay. Awesome. Before diving deeper into the problem, it would be wise to create a list of things that we want to look into. Let's do it. Okay, so the first thing that I will call it a plan. Let's write here, plan. So first thing that we want to talk about is the overview of the problem. Second thing that potentially is interesting is the data model. So here we'll be talking about the entities that we're going to use in our architecture. Third thing is the API. So we need to talk about API. Fourth thing would be storage, because we need cache. We definitely need to discuss storage. After that, we need to actually create our architecture diagram. I will write here architecture. And the last thing, usually on the interview, the interviewer is doing a deep dive in one of the problems, just to understand how well you're understanding your architecture. So here I will write just deep dive into one of the problems. Okay, so basically what we have here, we have a mobile app, iOS, and we definitely would need a backend here, so it's a client-server scenario. So we should go straight to data model. So what entities do we actually need here? So we have a friends list, and obviously we need an entity called friend that would be holding name, status, and the game. But the interesting part here that this friend entity consists of two parts. One is volatile and the other is not. So let's say the image, an avatar of a person and name don't really change that much. So we could save this and request it only once. But status, game playing, and last seen status. These things usually change a lot. That's why it would be smart to divide this entity in two. One would be a friend entity, and second would be friend status. So let's write it. The first one would be friend. So, and friends will have ID, which is an integer. Also, it will have name field. It would be a string. Also, avatar URL, and it would be a string. It's a really important point that we are not actually storing and returning from the backend the object itself, the image. Here we're just returning a URL, a string, and later we can download our image. It's made this way because we want to make our request for the friends list to be as much lightweight as possible. Okay, what else? Name, avatar, URL. That's it. And second entity would be friend status. Friend status. Here we would need to have a friend ID integer. Let's say it would be an integer. We need this ID to match this entity to the friend one, and between them we will have a one-to-one relationship, which means that for each friend we will have only one friend status. Okay, friend ID, integer, what else? Online or offline. So let's call this property status. And it would be, let's say it would be a string. What else? If a person is playing some game, we need a game name. Game name, and it would be also a string. What else? We need to show last seen string if the friend is offline for quite some time. For that, probably we need a timestamp when this person was last seen. Yeah. Let's say we need a last seen timestamp. I will just call it timestamp for simplicity, and it would be just like integer. Awesome, that's it. So the next step is API. Let's discuss it. I will write here API. Okay, so we have two entities that we need to request. The friend entity doesn't change often, and it means that we can use for our non-volatile data, we can use just a REST API. This is the most common solution and the most easiest via HTTP. What kind of request do we need here? It could be just a GET HTTP request that is called GET friends list. GET friends list. That would return all of our friends list. So we don't actually have a lot of friends. We have only 500 friends. And the object itself is not really heavy because we have only int string and another string. We're not holding any data like image in this object. So we can actually do this request in once. So we don't need to divide it in multiple. And it would be easier just to not use pagination here. But the interesting question is, how often do we need to request this data? So let's say we are requesting it every time we open our app. Do we actually need it? I don't think so. We can download the whole list of our friends only at the first time, and later we can just get updates. How to actually do this? So when we first time get our friends list, we save the timestamp when we did this request. And later, when we are requesting the same thing, we can just pass this timestamp. I will write here like request timestamp. For simplicity, I will write timestamp of our last request, and server will return only the updates. Let's say some person changed name, or we have a new friend, or we deleted someone. So we will just have these updates and update our list accordingly. Let's get into the interesting part, the friend statuses. So we need to update this data every 5 seconds. So what possible solutions can we have here? On a real systems design interview, it's really important to show the depths of your knowledge and suggest possible alternative solutions for this, and talk about the pros and cons of these solutions. So let's do it. What possible things we could use here for updating? The most simplest would be just to do polling. The other would be to use sockets. So we can use a socket here. And probably we could use push notifications with updates of statuses of our friends. Push notifications. So we can do the polling or long polling method, but it's not the best one. Why? Because we would need to do a lot of requests actually. Every 5 seconds we would need to send, let's say, get request, and it's a lot of requests, and there would be a huge load on our server, so I don't think it's a good method to use. What about push notifications? So we actually can send a silent push notification with an update of a status every time the user gets an update. But I would say this one is not the best solution as well, because on the server we would need to understand if the app is opened at the moment, because we don't know this on the server. And sending push notifications to all the apps of all users, which can be not opened at the moment, is not a good solution, because we would be sending a lot of redundant push notifications. And creating a mechanism to understand on the server if the app is opened right now and not, probably would be redundant as well. So I would say the best solution here is to use a custom socket. How it will work? Once the app starts, we will open a socket connection, and we will initially send a list of all friend statuses, and then later we would just send updates. Let's say someone has gone offline, so we would update and send a new friend status object for that friend. Amazing, we have our API more or less. Let's talk about the next part, which is storage. I will write here storage. And as usual, it's really important to show the breadth of your knowledge and to name a few possible solutions. So what we could use here for storing the friends list, because obviously we don't need to store friend statuses because this data is volatile. We just need to store the friends list. So we could use core data, or plain simple SQLite, or we can serialize objects, serialize objects to the disk, serialize objects. So how to choose a solution here? Core data usually is my preferred option to go. It's a really nice framework that is built on top of the SQLite, but we could use a simple SQLite as well. The advantage here would be that performance is usually better and we can customize it a little bit better, but we will have a lot more manual work. For this kind of simple app, I would suggest using core data. And what about the serialization and deserialization of objects? Yes, this solution is really simple, but the downside here is that we need to serialize everything or deserialize at the same time. which is not really good. So I would say we should use core data here. Cool, let's move to the fun part and draw an architecture diagram. Cool, so we have a client-server scenario, so we will have two parts here. The first part, and the most important for us as an iOS engineers, is iOS, and also we would need to briefly talk about backend. For the UI implementation, we have different architectures that are commonly used on iOS, and they are Viper, MVVM, or MVC. MVC is usually used for really simple apps, and view controller could become really big and unmanageable in this architecture. So it's preferably to use MVVM or Viper. Viper has more abstraction layers, but I usually prefer to do MVVM. So let's use MVVM for our app here. Let's start the diagram from the view controller. So here we will have our view controller object. And in MVVM architecture, we will have a view model. So view controller would be connected to view model. We'll just write here view model. Awesome. For working with API and storage, I would suggest adding additional layer of services and to create a service for each entity. So here from view model, we will have two relationships to service. First would be, let's say, friends service. And another one would be responsible for downloading friends statuses. So let's call it friends statuses service. Okay, so what these statuses, what these services would use. So we need additional space. So for friend service, we would need to have an HTTP client that would be doing HTTP client class. It could be made on top of the Alamofire, which is a really good framework for doing HTTP requests in iOS. So HTTP clients, and here we'll have our backend, and on the backend side we'll have a REST API here. So our client would be doing request here, and the protocol would be HTTP. Also, we wanted to store our friends, so we would need a storage, and here we can create additional storage class that would be responsible for communicating to core data and like storage. And this storage class would be communicating with core data. Here I will write core data. I think we need a little more space, so the service would be another place. Friends statuses service. And we need to connect this service to a WebSocket. So here, let's say we have a class that is called Socket Manager or Socket Client. Yeah, I think Socket Client is better because we have an HTTP client or REST API client. So we have here Socket Client. And on the backend, we will have this custom socket for the statuses. And here we'll have a connection. Okay, cool. So we don't need a storage for statuses because they are really volatile. What else? The interesting question is how we build up this dependency graph in the iOS app. So we have two possible solutions here. The first one is to use singletons for everything, which is obviously not the best solution because our code would be messy. And the other solution is to use dependency injection. So I will write here DI, dependency injection, and we can do it ourselves, or we have a lot of dependency injection containers. For example, for Swift, it's called swinject. So I will write here swinject. So we will use DI container swinject here, and it will help us to build dependency graph. So the view control would be holding view model would be holding friend service would be holding client and the storage, etc. Let's talk about the UI. So we obviously have a list here of cells, and we can do a table view or a collection view. I would prefer to use a collection view in our view controller here. To render our cells in the collection view in the view controller, we usually need to implement a data source where we will be creating the cells, but this could lead to a really messy code. So probably we could do a binding between a collection view cell and some kind of cell objects or view data objects. And there are a lot of frameworks for that. For example, one of the most popular is IGListKit. We can use it here in the view controller. So I will write here IGListKit, or we can do it with Eric Swift. The main idea is to bind collection view cells to their data objects. Okay, so let's go through our architecture. So the idea is that view controller is really simple. It doesn't have any logic, so it basically only renders our view, and it has IGListKit or some other framework to help us to bind collection view cells to view objects. View model is responsible for getting data from multiple services, just arrays of objects, and converting the data for view controller to render. Okay, and we have a service layer here, and we have a service for each entity. So we have two entities, friends and friends statuses, and the service abstracts for us how this entity is retrieved. So it could be, for example, for friends, it could be retrieved or requested from the backend via HTTP, or it could be going from the storage, just from the core data. And we don't need to view model to know that we have a storage or some other implementation. This is really useful solution to have this layer of services, because in the future we could change, for example, the backend, or probably we don't need storage, or we want another storage. So this way, view model will just requesting data easily. Here we'll have a method like something like just get friends list, as simple as that. And the friend service would have a logic in what case we should take data from storage and how often do we need to do requests. It's really nice to have this abstraction. Okay, and we will have a HTTP client, basically just a class on top of LMifier or IF networking for Objective-C that will be doing HTTP requests to our REST API on the backend. Here we'll have just only one method to return a friends list and via timestamp. And we can hold timestamp in the NS user defaults, and basically our friend service can work with NS user defaults. So I will write it here, NS user defaults. And storage and core data for storing our friends objects. And here we just have a status service and a socket client that would be getting updates and holding the data for the last statuses updates. Okay, cool. So that's our overview of the architecture. Usually on the interview, the interviewer would be asking you to additional questions to dive deeper in some parts that he's interested in. For example, he could ask you to dive more into how UI implemented or how services are implemented. For example, how this last seen 2 days ago string is generated, or just go through the data flow. But I decided to deep dive into image processing for the example. Okay, so from our REST API and friend service, we will get here in the view model and view controller just image URLs, but how to exactly download the images. So you probably know that we have on iOS a lot of libraries like Alamafire images or SD web image to download images, but it would be nice to discuss how it works under the hood. So usually we will have an cell being created here in the view controller, and we would need to assign an image to our image view. So we will have actually in our pre-made framework like SD web image, or we can do it ourselves. So we will have a category on UI image, something like UI image plus image downloading. Okay, so what here would happen? We would do a request for our image URL, and we will have a queue of basically a lot of requests. Why we're doing a queue? Because it's possible that the user would be scrolling through the app really fast, and we have a lot of images to download here. So if we need to, we can actually cancel requests for images, UI images that are off screen. So we'll have a queue here that would be saved as the binding between, let's say, image URL, and request. So here we'll have a binding between image URL and, let's say, NS request. So if the image goes off screen, then we can cancel the request. Or, for example, if the request is completed and it comes back, then we can just see if this image is presented on screen, and if it is, then we can update this image. Another interesting question is, do we actually need to cache these images, and where? In the memory or on a disk? So I would say we need to cache them in both places. This is really important, but we would need to have a limit of the of time or the just amount of data that we are storing. So let's say we are storing images on disk for 1 year. It should be enough. So if we don't have enough space for our app, then we can store images on a disk for, let's say, a week or a month. All right, I think that's it. Let's wrap it up. Guys, thank you for spending time with me on this question. If you want me to do more of these, then please like this video or comment. It really helps to promote my channel. Thank you for watching, and see you in the next one. Bye.